Why does space not have light, but Earth does? If the cosmos is filled of stars, why does it appear to be dark? Heinrich Wilhelm Olbers posed this query in the year 1823. From there, the well-known Olbers paradox emerged. It teaches us that the night sky should be bright and devoid of any black areas, since the stars would illuminate every part of the sky in a static and infinite world like ours, with infinite stars and limitless space. But if there are many stars in the universe, why does it appear gloomy at night? Introduction: the reason why we see star beads on a black background whenever we look up at the night sky is because the sun is lighting up the side of our planet where it is daytime when it is night on Earth. But if that's the case, why is only the portion that faces the sun lit up? In other words, why is it dark somewhere in space yet daytime here on Earth? This is caused by a phenomena in optics known as reflection, which makes some things reflect the light that enters them like a mirror. You probably already know that the atmosphere, which is made up of numerous layers covering the globe, contains a variety of gases. These are the ones that capture the sun's light rays and then reflect them back toward the Earth, creating the day. If there were no atmosphere, even on the side of the Earth that faces the sun, it would always be night, exactly as it is on the moon. Few people are aware that the moon has day and night, much like the Earth, although the lunar day does not appear the same as the Earth's day. On Earth, everything is fully lit up during the day. On the moon, however, the sky is still dark even if the sun illuminates the whole surface of the moon. No atmosphere, after all, blocks the sun's rays. On the moon, the sky is always gloomy whether it is day or night, since there is nothing to catch the sun's light. Why is space so blue? It is only reasonable for us to question why space is so dark at night if the cosmos is filled with stars and galaxies. Where are all the stars, nebulae, and galaxies that make up the stunning scene captured by space telescopes? We believe that we may see those vivid and bright celestial bodies by gazing up at the sky or using inexpensive, simple amateur telescopes because of the breathtaking images taken by telescopes like the Hubble or the James Webb. Our eyes, however, are unable to perceive anything save the stars. When we search for images from space agencies like NASA, we obtain images of the Moon, Mars, Pluto, or Saturn with uniformly dark backgrounds devoid of stars. Rather than astronomy, photography is the cause of this occurrence. Unfortunately, space organizations don't send telescopes and million-dollar probes to snap stunning pictures to sate our longing to see stars in high resolution. These are only employed to research the universe. You must take images with an extremely fast shutter speed and a very brief exposure due to the lighting conditions in space. However, capturing the stars well calls for a slow shutter speed and a protracted exposure. In other words, engineers in charge of huge space telescopes must decide between taking a flawless image of Saturn against a black background or a flawless image of the stars in Saturn's background while allowing Saturn to seem fully white due to too much light. The issue is not all that unlike from the standard concert photo with a flash. Although the foreground object's lights make the backdrop appear black, if we wanted to snap a picture of the background, the foreground objects would appear hazy and too lit. In defense of space agencies, space images are not always captured in this manner. Beautiful images have been captured from the International Space Station, and with enough time and a good camera, we can view the Milky Way and a truly amazing space panorama with billions of stars thanks to the slow shutter speed and low ambient light. Because they concentrate on distant corners with no background objects reflecting a lot of light, space telescopes and other sensors likewise get flawless images. Not to mention that they frequently capture images at wavelengths like infrared or ultraviolet that are invisible to the human eye. Additionally, because it was daytime on the moon and the sun lit up the lunar surface, it is because of this that you cannot see the dim light of the stars in any of the images that the astronauts took while they were there. You can find images of the moon landing with stars visible in the backdrop, though, if you look closely. The adversaries of light are spacing and time. Two ideas that have existed since the beginning of time, space and time, are at the center of the current theory explaining the universe's darkness. We are aware that the universe is so vast that we can think of it as endless. The cosmos is thought to have started between 13 and 14 billion years ago, according to modern astrophysics. The universe's fastest substance, light, travels at a speed of 300,000 kilometers per second, but even at that speed, light cannot traverse the entire expanse in a single instant. In other words, even if we gave light an infinite amount of time, it is never completely covering the sky as space moves away faster than the light itself. Space is black because most of the light emitted by stars has not yet had time to cover the entire universe and likely never succeeds since the universe is expanding faster than light. Even though the cosmos is 13 billion years old, light sources like stars are not as old. This is the second aspect of the issue. Most of the stars that we are aware of date back between 1 and 10 billion years. The paradox of Olbers. The presence of opaque bodies in a ratio equal to that of stars was one of the earliest explanations for Olbers' conundrum. If we assume that the universe and its stars are infinite, then it stands to reason that its opaque bodies must likewise be infinite. Now that technology has advanced, we are aware that the universe is not as empty as we formerly believed. Contrarily, it turns out that there are enormous hydrogen cloud concentrations that can only be observed with infrared light detectors in the region between galaxies. This would act as a barrier to light, preventing it from reaching Earth in all observable directions. The issue with this idea is that since energy cannot be generated or destroyed, if these opaque bodies were to receive light from these limitless stars, they would eventually heat up and release the energy as light. Therefore, it is safer to assume that dust clouds between galaxies are either not as dense as thought or are not as prevalent in all galactic clusters. The growth of the universe. Another hypothesis holds that light becomes weaker as the cosmos expands. The Big Bang, which is a zero-point event, is where we know the universe began to grow. This expansion has an impact on how light travels because as it expands, its wavelength lengthens until it enters the infrared spectrum, which is invisible to us. The issue with this notion is that ultraviolet light ought to be converted for us into visible light. Even yet, it's possible that there isn't as much radiation of this kind. The best explanation for Olbers' paradox is that light hasn't had time to travel through the unimaginably huge darkroom we live in, and many of the star bulbs have already burned out. It is possible to prove that the universe is finite even without employing the Big Bang theory, which would resolve the Olbers' paradox issue and explain why the sky is not totally luminous. The universe contains a significant amount of hydrogen, as is well known. However, this sum gets smaller over time. This is so because stars use hydrogen to produce heavier elements like helium. The process of turning hydrogen into heavier atoms would have been finished if the cosmos were limitless. Hydrogen is a very abundant element in the cosmos, contrary to what we may believe, which leads us to believe that the universe is finite, just like time. This answer might be called into question, though, if a technique could be found to reverse the process, turning heavier atoms into lighter ones up to hydrogen. Today, however, it is a process that has not been witnessed naturally, suggesting that the cosmos is a finite space-time and, consequently, the stars are also finite, so they could not totally illuminate space. We can't see the light. The following query is for you to explain why there is light on Earth but not in space. Are you certain the area is dark? The response to this is, it depends, as if the space seems black to us, it may not be to other creatures. There is a specific kind of stuff that permeates every region of the universe and fills space. This sort of matter is known as dark matter, although its exact nature is unknown. We also know that the empty regions between star groups and galaxy groups are covered by enormous clouds of cosmic dust. The only way to observe these clouds is with infrared light. We can see light that our eyes cannot perceive when we observe the universe with spectroscopes or radio telescopes because visible light is the universe's minimal amount of light. Although the cosmos appears empty and black to our eyes, when viewed through the lens of science, we understand that we actually live in a highly vibrant and intriguing universe. Would you like to hear more about the dark energy or dark matter that surrounds the entire cosmos? Please tell us in the comments. Thanks for watching.